I All right, I can start over again.
Yeah.
I'm Italian, and I start my career there. I got an undergrad and master in geology with a focus on natural hazards, and then I did a PhD between France and Canada looking at landslides on glaciated volcanoes. So I start to get more into the climate component of hazards, so see how the ice melting that is due to climate change is affecting slope stability on volcanoes. And then from that, I kind of start to move from the hazard component, so it's just like quantifying how big are the landslides, how frequent they are, to the risk component. So what is the impact of this landslide to humans? And then when I joined Minerva, I start to look at using new technology, AI, artificial intelligence, machine learning, to better quantify this hazard and then the risk. And then first we were focusing more, I guess, on the hazard component, and now we are really focusing on the climate component and how the climate is affecting everything, including the hazards. And then from that, the risk component. So what is the impact on society of this climate change or events that are increasing because of climate change?
Mm. Now, was there like in your background, when you started, when did you start your undergrad? Well, I guess I shouldn't ask when did you start undergrad, but when you started, at least when I started my undergrad too, which I presume was not, maybe in the same time frame somewhat, climate change was an issue, but it wasn't like the dominant issue. It was like, a lot of, in fact, and when I started, it was endocrine disruptors and other things were like really the hot things at the time. What really was there any pivotal moments along your academic training and professional career that has caused you to pivot and look at certain things?
Yeah, I guess I study geology, and geology, at least in Italy, we do both more environmental, natural hazard, and hard rock geology thing. And I got interested straight away on the hazard component of the geological world, and then the risk involved that is tied to the hazards. But then like the focus on climate change really came into more recently, because I think as a society as a whole, like is harder and harder to look away from the problem, right? So up to a few years ago, you will find you were finding a lot more climate skepticism, but now it's so in our face that we cannot look away anymore. And so is related to my professional career in Minerva. We started more on the AI component, like focusing on algorithms and things like that. But then in the last couple of years, we really shifted the focus on the climate risk component, because that's what society needs the most. Like in Canada, it's really hard for people to get access to climate risk information. There's not an easy way for a person to look at the probability of the house being flooded or burned by a wildfire or affected by extreme precipitation or wind or all the other hazards. While in some other countries is slightly easier. In Canada, it's specifically hard for people to get that type of information. And so, yeah, I always like to try to do something useful with my career, right? So I like the idea of helping people somehow. So that's why I really like this the focus on climate change and the risk.
And in terms of Minerva, you've mentioned the company and we've mentioned them, but like give us a bit of background on the company itself. Now, you've been with them for 2-3 years now, or how long have you been with them?
What was 2019? I guess 3 years. Yeah, the company has an interesting story. It began as an artificial intelligence company in geology, like more on the economic geology side of things. The founders are a professor of computer science from UBC, David Poole, and Clinton Smythe, a geologist. And the idea was to produce mineral exploration map using I guess a decision support system or an AI system, you can call it. And then when they hired me. We started to apply the same algorithm, not to find gold and other metals, but to actually map dangerous locations. So which slopes are more likely to fail, and which areas are more likely to get flooded, kind of thing.
Mhm.
And from that, then now I guess we have two main products in the company. One is focusing in the economic geology world, and is to basically reconstruct 3D geometry of geological bodies. So from drill hole, from the geochemical distribution of elements, we reconstruct the ore body.
Mhm.
And then on the climate side of things, we started to produce Canada-wide data set to quantify probability of say heat waves and precipitation and fire and flood given different climate change scenarios.
Mm.
So this is kind of has been the evolution. So now we put more focus on producing this data set than on the algorithm themselves.
Mhm.
Yeah.
And so currently the groups that you work for, like as clients, are a range. I imagine you have some mining companies and some resource companies that's kind of in the backlog of what you originally started with, and you probably continue to do that with some product development. But with this new direction you've moved in over the last 3-5 years of risk assessment, either geophysical risk, landslides and so forth, and now climate risk, have you found your client base has changed at all? Do you have like more different agencies that you deal with and different organizations, like insurance companies? I imagine are probably interested in what you're doing.
Yeah, I guess we started more from a professional engineer and geoscientist as a target customer, and then we evolved into more financial sectors, because there's I guess one of the major, I forgot to mention it, but there are new regulation in the financial world where um, companies need to disclose, next to market risk and credit risk and other financial risk, the physical climate risk component. So what is the likelihood of the company's asset to be flooded and
Mhm.
burned by a wildfire?
Mhm.
And this is new regulation that is coming out, and this really boosted our effort in the shifting towards the climate risk component of the natural phenomenon.
Mhm.
And so now we are focusing more on financial sector,
Mhm.
because they need this data to disclose their risk.
Mhm.
And then for sure, the insurance sector is a big one, but traditionally they have developed CAT models, catastrophe models, that now also include climate change projection, and
Mhm.
so it's more is a more competitive market. So we have a variety of initiative. We also have some government projects and things like that. But I think the biggest opportunity is in the financial sector.
So one of the courses that some of the students here, grad students, are from a course in environmental accounting and reporting. So looking at how do you go about attaching economic value to these kind of parameters. So when you're tasked with that challenge, so with this new regulation coming down, like risk disclosure for organizations, whether they publicly listed or whatever it is, you guys were going to provide them with the climate risk or the catastrophe risk for a flood or a wildfire, whatever it might be, biophysically. Where does the financial, like who comes up with the financial impact? Is that them, or is there another third party that does it?
Depends. We have ESG reporting firms that we are partnering with, so they would provide the complete service of building the ESG disclosure report and things like that. So we would just provide data to them. Some other time we have the client itself would have a climate risk team in the company, so we would provide the data and they would work with the data. But we focus a lot on the data side of things,
Mm.
and then because different sectors have different needs. So say the insurance use case needs the data packaged in a certain way, while a financial institution needs it in another way. So
Mhm.
the best way for us is is to focus on the data, and then we work with them on how they need to report or how they need to get insights out of the data, right?
Okay. Now, there's obviously, as you see, and most people see in the tech industry, AI has kind of become a ubiquitous term, right? AI. I have meetings where I get financial people saying, "Hey, we'll just use the AI to do that." And you're like,
Right.
"Do you really know what you're doing? Do you really know what that means?" So I was wondering if you could just explain to everybody, like, what in this particular context in dealing with these kind of problems, what is AI and how is it used?
So yeah, you said it right. AI is a big buzzword, right? So in the AI world, we kind of can identify two different streams of AI. One are the data-driven AI system, the machine learning, where the algorithm will find patterns in data without being specifically instructed on how to find the pattern, let's say. And then you have the more classical approach, they are more rule-based approach, where the humans will set a lot of rules based on logic, and then the software will follow the rules and help out with recommendation. So we use a combination of all sorts of methods because that's how usually things go. In some cases, if we have enough data, we use data-driven methods to get insights, and then some other times we use more rule-based system. And we have patents in both topics, both for more data-driven and rule-based systems. And there's pros and cons in the different methods as well. So yeah, I don't know if this is very clear. I guess there's a lot of hype on the machine learning side of things recently, especially on pattern recognition in images. So all the deep learning side of things, and is used in a successful way for, say, self-driving cars, for example. So there's a feature extraction algorithm and classification of pictures. So then the self-driving vehicles can know where to go, kind of thing. And as well, like in the identification of object in images, there's the whole deep fake wave of things that is using those approaches in not a great way, I guess. But yeah, and these type of techniques are useful for classifying satellite images as well. So there's a lot of feature extraction tools based on deep learning algorithm. Now, we have tested some deep learning for some use cases, but for most of climate modeling tasks, you don't really need that type of machine learning approach. Even more classical statistical methods are good enough to deal with climate models. Yeah, I don't know if it makes sense or.
Oh, it does. One of my colleagues I did part of my undergrad at Waterloo in systems engineering, and Joelle, one of my colleagues, went on to be the AI person. So she runs Facebook's AI lab out in Montreal. She's a prof at McGill Joel Pinot. So she knows all the the big shots at Mila and so forth. And I've sat down and talked to her a few times about it, because I just hear it like AI. I said, well, Joelle, we're having a coffee. How would I use this? Like, and what I do and what we do in my team. She's like, well, do you have large amounts of data over a time series where we could run some bots or some algorithms to just look at characterizing abnormal patterns that occur and characterizing how they might occur over future timeframes, to have some sort of predictive capability? And I was like, yeah, we can do that. And she goes, well, yeah, that's like one of the most basic things you can do with respect to, like, say, time series analysis of whether it's climate data or land cover data or something like that. So I don't know. I think there's a lot of hype around these things sometimes. And when you get down to the meat and potatoes of what the problem is, it's a lot simpler than what people purport it to be.
Yeah. And especially like for climate models and things like that, those, or even like to model flooding and things like that, those are more physical based models. So you encode the laws of physics, and then you let the model run. So it's based on physical properties of materials, right? And then so that's and for climate models, we don't know how the climate will be. So again, you build a very scenario-based model, and you make some assumption on what might happen, like CO2 concentration and things like that, and then you see how the Earth system will react, kind of thing. So those are scenario-based, and in geology and as a whole, as a field, is very hard to apply machine learning because, as you said, you need a lot of data, and in geology it's very hard to get data because there's a lot of field data that needs to be collected, and then the data collected is not always in the same standard, so it becomes hard to have big geological databases. So there's a lot of effort in standardization of databases for geological application, which is a big task. That's the whole standardization problem. Because again, so we are one of the projects I'm following now is we have a MyTech student at UBC, and she's working on testing an algorithm to basically learn some feature from a data set, and then apply the learned feature to a new data set. And it's super hard to do. Just even to find two data sets that are compatible is very hard, because you need to have a set of feature you can use to learn another feature. Then you need to have two databases that have the same set of features, and it's not as straightforward as people might think sometimes. So there's a lot of work that needs to be put in the data collection part of machine learning, because you need the data, and then you need to run the algorithm.
Now, for at the initial discussion, when I got kind of bailed out of the chat, I heard some of the talk about what's happening right now in Europe and so forth. Now, so in terms of climate models, are you guys just using climate model output? How do you guys use climate models? Do you run the models themselves, or using climate model output from other sources like the Hadley Group or whomever? Do you use downscaled models? What do you guys use for your work?
Yeah, so the climate models are run and maintained by research institution.
Yeah,
and they are publicly available. So what we do, or what is the climate best practices of climate modeling, is you take an ensemble of climate models, because you cannot trust just one model, because some model will perform in certain zones, or maybe in predicting some variables. Maybe one is good for wind but bad for temperature, and maybe one works well in northern Canada and the other one works better in the tropics, and things like that. So you need to get an ensemble of climate model, and then you look at the ensemble means, and you extract variables taking into account the spread of value across different models, right, to minimize the errors. Once you do that, then you need to bias correct the models. So that means you take the climate models, and you can you usually look at weather station data. So, and then you correct what the climate model says with, you have a baseline of data that is what happened in the past, and then you look how the climate models recreate the past data, basically. And then you need to do that correction for the bias, to take into account the biases. Once you do that, then you need to do the downscaling, because the climate models usually come at 32 kilometer resolution, and then you need to take into account topography and other local effects. So then there's different way to do the downscaling as well. And then machine learning these climate models are mostly physical based. There are new studies that look into how to use machine learning for different steps. Maybe it's for the bias correction, or for the downscaling, or for some other component. And most of I see the question, software method. Okay, I don't know what the design.
That's us. Well, I can answer that one. But
yeah,
for Michelle's question, what kind of AI methods are being used for recent IPCC reports? I presume not much. Is the IPCC doing anything with AI in terms of, or I guess pattern rec maybe, but
yeah, I wouldn't say so. Like, it's mostly physical based model,
right?
But I might be wrong. There might be some processing component that you might be able to classify as AI, depending on how you define AI. But mostly they're physical based model.
Yeah. Actually, I'll jump in on the second part of this question, because Michelle's referring to some of the work that my team and I do outside of rural roads, in which we work with countries to help them manage their environmental data. And Gio, you and I and your colleagues have talked about this. Mostly what any given country will have, in fact, especially developing countries, is they're going to have pretty rudimentary data sets. So like Caribbean countries, Antigua or Belize or whomever, what they will have is they will have good Met data. Every country will have a Met station at the airport. They have to. And that data set tends to be pretty old in these countries. So like you have 100 years of rainfall and wind and solar radiation data. They'll have that. But in terms of anything more sophisticated, they're basically looking at patterns over time to see if there's been anomalous changes, right? And it's mostly meteorology. I wouldn't even call it climatology work that they're doing as up to now. Only in the last year or two have I encountered Met services in these countries that are getting climate scientists working with them, meaning they're looking at longer term variations as opposed to just the weather. So there's that. And then in terms of how that relates to any kind of climate decision making for these countries, again, it's pretty basic. And hopefully as we go forward, Gio, you and your team, we can start to work more together to provide more advanced data sets to these countries. Because currently right now, what they'll use like a NOAA output for sea level rise, or they'll get some like a regional climates group. Like there's one in Cuba, for instance, at a university in the 5 Seas in Belize, and they'll produce like some climate model output that can be used by these countries for some rough planning. But other than that, there's not a lot of, that's not parameterized, like they don't test it or anything. It's just basically historical Met data and then a few climate maps, basically what's, projected drought risk in the next 50 or 100 years. But other than that, that's the most basic, that's what I see in terms of actually being used right now. So in terms of the limitations and possibilities with what you guys are doing, like what can you really do quite well? Like where are the wins that you can get, and where are the limitations that you foresee in terms of dealing with some of the problems that we're starting to see right now from a kind of risk standpoint?
I think the main limitation are still from the human component. I would say, like the slow adoption of climate risk mitigation strategies, right?
Yeah.
Lack of investment, lack of policy. Like even if we look at BC, like we had the flooding last year, but if you look at the science, if you look at the engineering reports, was everything mapped out? They knew it, but then was a lack of initiative or political support to do something about it, right? So it's always like, even now we talk about climate crisis, but the scientists have been talking about it for the past 40 years, right? Or more since the 60 or 70, the very first report about the impact of fossil fuels on the environment. So then we cannot, the models are not perfect, right? But they provide enough information for people to take action, right? So I think the main limitation is not on the data, on the models, is on people understanding and taking action about it.
Well, like for instance, to hear, and I haven't looked into, in fact, a friend of mine said to me the other day, "Oh, you must be busy working with the British Columbia government after all these floods last year." I said, no, not really. It's like all it would take would be to do, some topographical maps, run some risk models for, flood risk and drought risk based on climate and hydrological models, and you could come up with some mitigation strategies for avoiding some of those floods, I presume, right? Like, I don't know, what would you, if the premier were to call you tomorrow and say, hey guys, we need to deal with the potential, we need to abate some of this risk, how can you help us out? Like, what would you guys do for Fraser Valley flood risk?
Is like prioritize investment for adaptation. So that means the flood maps are there, the risk maps are there. So then you need to rank the assets at risk, and then say, okay, you need to deal with this problem first. And all the data is out there. Then the question goes to how much money can you invest to do the necessary upgrades. And one of the main problems is the diking system, right? The diking system needs to be upgraded, and one of the problem, again, it goes like, who is responsible for maintaining the diking system?
Mhm.
And so then is for example, if we take the diking system example, you need I guess what's the word, like a holistic approach to map diking, the diking system, and a systematic upgrade of the diking system that is not at the municipal level, but is at the provincial level. So and it, for me, it's kind of interesting because in Italy the same thing happened in the 70s. There were big floods there, and so the flood mitigation went from being a municipal problem to a new created institution that is, they call it like the hydrographic basin authority. So each hydrographic basin has an authority to take care of that hydrographic unit, and so that they had a consistent response to flood for the whole hydrographic unit, because the hydrographic unit doesn't care about the border between municipality or provinces. And so then you need to have a administrative unit that are mirroring the landscape, and they don't cut a river basin halfway, because otherwise, if half of the valley adapts and the other one doesn't, then you still have a problem, right? And so that happened in Italy in the 70s. There was a very bad flood that and people reacted in that way. I feel here things are moving in the same way. But I'm really curious to see how things will evolve, because then every country will have different responses to different problem, right?
Now, are you, so this kind of leads to my next question, was how does your work intersect with, in some cases you're responding to regulatory requirements, like say, for instance, for climate risk disclosure, there's a regulation that's causing you to provide some support to some groups, right? In other cases, like this recent grant you guys got from, is it DFO that's giving the coastal zone stuff, Department of Fisheries and Oceans, or is,
I guess the sponsoring
or
is an Innovation Solution Canada grant, and the DFO is one of the stakeholder,
right?
I guess.
So DFO, NRCan, those kind of groups are getting together. Now, will that work that you guys are doing in coastal risk assessment, because maybe you want to explain a bit about that project, but do you think that's going to, there's part of you as a responding to regulations, but I assume that the work that you're going to be doing there is going to help inform better regulations for coastal zone management, right?
Yeah. In that case, we can look at that project as a proactive effort.
Right.
So, and is the objective of the project are twofold. The first one is to have a data portal where all the data, or the relevant data to the Canadian coastal zone, are stored. So there are different use cases. One is like engineering practitioner can just log into the platform and get all the data set they need for more specific modeling. So they will find bathymetry, they will find climate change scenario outputs, so that they can do more precise wave or wind modeling and things like that. Then another use case, and there are some built-in computational tools to do that, is for asset managers to rank small craft harbors with respect of climate risk, so they can quickly see which harbors on the Canadian coast are more exposed to sea level rise, or surge waves and and extreme winds and things like that, and so that they can invest for adaptation. They go like, okay, where do we need to invest for sea level rise? Where do we need to invest for windstorm and things like that? But yeah, that project is very interesting and exciting, and now we build this prototype, and we're gonna see if we're gonna build the full functioning platform. But is really cool.
So and earlier on in our discussion, you said one of the things that motivates you personally most is working on things that are helpful to others. You know, you're kind of quote unquote making a difference, or you know, informing society to you know, improve people's well-being, abate risk. So as a whole, like what do you see? I mean, I know you're not like the only person in Minerva, but you play a key role in terms of the tech development. What kind of role would you like to see Minerva playing as a company, and you as an individual within Minerva, in terms of sustainable development or sustainability? Like what do you what could be your guys' contribution, or what would you like your contribution to be?
Yeah, I really think we could become, or hope we become, like a leading Canadian company for everything related to climate change adaptation. And you know, if I look at the US a lot and other places, like in the US there are tools where people can just type an address and get the likelihood of flooding and wildfire and things like that. In Canada there's nothing like that. So you know, beside more financially focused initiative, I would really like to give the possibility for every Canadian to be able to type in an address and figure out if what's the probability of losing their house during the duration of their mortgage, for example.
Right.
And I really think for me it would be a success if Minerva can lead the way to this type of information for people. And,
do you think the democratization and access to the information such as that can make a big difference? I mean, I agree with you. I think it does, because in some of the work that we do, we see like open data and access to data makes people more aware of some of the problems and opportunities that exist, you know, like in terms of some of the countries that we work.
Sorry, what's the question?
Well, as like, do you think that access to information, open data, and in giving people those kind of tools, do you think that can kind of have that kind of a difference? Like, do you think it can motivate people to behave more sustainably, and also, you know, make society and individuals, and as well as governments, make better decisions about things?
Yeah, for sure. Because if people are more aware of the impact of climate change or their everyday life, like they see the probability of the house being flooded or burned by wildfire and things like that, then they can also put pressure on government to be more responsible and to push for a policy that are focusing on reducing carbon emission and things like that. So if you have a more informed citizen, then you might have more informed political class, and then things might happen.
Well, I really like the vision of where you want to go with Minerva, like that, like, because that's kind of like, I can see some parallels between what we want to do with some things as well. And I think I can see definitely some collaboration. Questions from people in the audience, in the crowd. Does anybody have any questions? We don't want to monopolize it with our discussion. We want to hear. I know there's some comments before. I think it was Melissa. I'm not sure who was asking me questions. Questions, anybody? Crickets. There's some. Yeah. Hello.
Yeah, can you hear me now?
Yes.
Yes.
Melissa, go ahead.
Perfect. Interesting, you were talking about diking. I worked in a First Nations community on Vancouver Island. We were a diking authority, a community in floodlands alongside a river. So lots of work around what to do, impacts in the watershed from forestry coming down, impacting as you get into the floodplain. And so First Nations are, you know, often in vulnerable landscapes, put on reserves that may not have been optimal land. And so there's a lot of work needing to be done in these communities. And so that ownership of that data is really critical for them. And so just wondering how you work with Indigenous communities and their ownership of the data if they were to work with you.
Yeah, we never had the opportunity to work with Indigenous community, but you know, the ownership of the data stays with the community, right? We would use it for making, you know, calculation and whatnot, but then we stay within the community. Yeah, and the ownership of data is like the Canadian landscape of data is very fragmented. Like there's a very spotty landscape. Everybody owns a piece of the data. There's no consistent standard for data creation and sharing across provinces or across municipalities. So Minerva worked with NRCan to define the standard database to store flood maps, for example. And that's a big effort that NRCan is undertaking, because if you look in the US, you know, you have FEMA, you have national flood maps, you have insurance, an insurance framework based on the FEMA flood map, right? In Canada, there's nothing like that. They are working towards that, but as of now, there's no way to compare a flood map from BC with a flood map from Alberta in an easy way. And then this is a provincial level. If you go at the municipal level, like a flood map from Squamish might be different from a flood map in North Van, right? So things becomes really difficult in terms of risk assessment. And so what we would do probably would be looking at the data that the First Nation have, see if we can map it to some other standard, maybe the national standard that has been under development, or maybe some other BC standard or whatnot. So then you can start to put things in the context, which is super important, because if you can't quantify and compare, like, it's very hard to then take the right decision. And this is like, now I was talking about Canada, but Europe, it's happening the same thing at the European level between countries, right? So, you know, if you take the Danube River, it goes across, I don't know, many countries, and the maps between countries are not comparable. So then if you have an environmental disaster or a flood or whatnot, it's very hard to coordinate a response between different countries, right? And the same, or if another example is the border between Canada and the US in Vancouver, right? The flooding, you know, some of the water, the flooded, the Fraser Valley was coming from the US, right?
So you talked a bit about working with municipal level challenges. Do you guys do much work with municipalities at that level in terms of risk assessment, or is it mostly at the provincial and federal level in Canada?
I guess as of now, we have mainly worked at this federal level, but you know, we could work with municipalities as well.
Okay. Other questions? That was a good one.
Maybe I'll just follow up to that. You know, it is interesting. More and more responsibilities seem to be downloaded to the municipal level. And that was one thing that we definitely noticed, that we had to collaborate with our local municipal jurisdictions, because obviously watersheds cross political boundaries. And we had to do that updating of flood mapping before we could even make any kind of decision making around what to do around that hard infrastructure around, you know, do we do more diking? Do we do sediment removal, log jams? All of that kind of work was needed. And it was really a barrier for us in those decision-making roles, that we had to do all of this work just to try to collate all that data so that we could make some good decisions moving forward to address those risks. And so I'm seeing that more and more in British Columbia around risk management, and that responsibility being downloaded to that municipal level. And I think it's a real risk that we are having, because we don't have data sets that maybe are speaking to each other, right? And so then it is really difficult to make decisions in emergency situations.
Yeah, for sure.
I have a question that kind of relates to that. Have you guys done much work on public consultation, even with the federal projects, where you're called to a meeting to talk about, say, for instance, climate risk in the coastal zone or in some location. Have you guys done that before? Where you?
Yeah, for sure. Like there's always a stakeholder engagement component that happened for the flood project. Also, we work on updating the hydrographic network. So as well, there was stakeholder component. We also work in assessing the data readiness in terms of sharing for geological data. So we did a survey of all the geological surveys in Canada. So how ready is the data? And we did a consultation with the survey, with the data user. So in this type of exercises, you always want to have the stakeholder involved because you need to produce a data set that is useful to the stakeholder. So if you don't talk to them, it's hard to produce something useful.
And so leading to that next question, or that response, what have you found is what people resonate the most with? Because a lot of the folks that are here either work in some sort of environmental management capacity or will work in that capacity, and communication and getting people aware of, you know, what are the problems and what are the issues, what are the real risks, immediate risks, as opposed to maybe some things that are, you know, have a greater perception of a risk, but perhaps are not that as dangerous. What have you found in your experience with these stakeholder meetings and consultations? What have people resonated with? What works with getting across the message with people in terms of media and approaches?
I mean, the stakeholder landscape is very diverse. It depends on the different groups, but their current topics are often about ownership of the data, and then like really you might go down to the format and the use, and again, depending on the user, there are different the stakeholder. There are different ways to get the message across. But usually the stakeholders are pretty receptive on the problems because they are affected by it every day. So when you go and talk to them, and like, oh, like finally someone is asking me about this problem, right? So they're usually very very open to collaboration, and usually we have a questionnaire we send around and then follow up with in-person conversations sometimes, or just a call on Zoom or something like that, and then we collect the feedback and analyze the data and plot it and see what has the highest priority and things like that.
Have you ever combined in those projects where you've undergone such an analysis? You said you have some first-person conversations with people. Do you ever have in a report or in your analysis have like a qualitative description of something, like, for instance, if say we're doing the coastal zone stuff, looking at talking to people that have lived in the area for quite some time to get their take on how things have changed, have there been extreme events before, how have they occurred, and then try and mesh that kind of qualitative local knowledge with model output type of data? Have you had that?
I guess we never done that type of consultation in terms of looking at the impact of events with people, but we had other example of more qualitative interaction. And so usually we try to, even if qualitative, we try to break it down in classes that we score in some way. So then we go from a qualitative assessment to a more quantitative way to describe about that assessment.
Right.
So yeah, that's how we usually do it.
Okay, good. Anybody have any other questions? Elsa, I just saw you arrived. I know you've always got some interesting perspectives on things. I don't know if you have any questions or comments.
Apologize. I was totally waiting in the other room, so I messed that up. So I'm just playing catch up right now. Sorry about that.
Oh, it's okay. No worries. Any other questions from anybody? Oh, here we go. Michelle. Tofino, some have built qualitative data would be cool. Here in Tofino, some long-term residents living on the water have built makeshift measuring poles for like looking at sea level, or what for? What do they get? Sea level. Okay.
Yeah, that's a tricky one in Tofino because you also have actually uplift because of the subduction, right? Yeah, that is dropping because that's is a locked fault, right? Yeah, exactly. You know it all already.
Yeah. Interesting. Any other questions? We're closing in an hour, so typically we're around this time, so it's good. Well, I wanted to thank you, Gio, for coming on with us today. Really appreciate it. It's really great to see, you know, people working on this stuff, you know, like we hear what drives me nuts is watching the news, especially now, and hearing the kind of like the climate crisis and, you know, just this kind of, I won't say rhetoric because I don't want to belittle it, but like just the noise around the issues. And then when you get down to actually like, okay, well, what are we doing about this stuff? Like who's working on certain aspects of it? And to see that you guys are like, you know, using physical concrete tools, process models, and machine learning and AI to, you know, inform decision-making in a variety of different ways. It's nice to see that occurring. And we hope that, you know, we can see more of your work, get the airtime that it deserves. And certainly my team and I are going to help with that for you guys. And hopefully those that have attended tonight from the university and other places have a little better take on, you know, what one does when they work on climate stuff, or when they work on these kind of risk problems. Like what does a day look like? Like what are the kind of tools that are used and methods? So thank you very much for coming out. Really appreciate it. Thanks everybody for showing up tonight. It's recorded, so those that are seeing this later, if you have any questions about what Gio is doing and his team is doing, so the website's Minerva. I'll share the
right.
It's minervaintelligence.com, is it?
Yes, and we also have a specific website put in the chat for the climate product.
Oh, there we go. He's frozen.
Hey,
There you go.
hello.
You're back. You froze there for a bit.
Yeah.
So you have this Climate 85. This is your specific climate project.
Yeah. I was just saying, as I froze, that we deliver the data via API, and also we are building a dashboard. So those will be released in the next couple of weeks or so. But yeah, like also if you have a question, you can reach out, and be happy to discuss more.
Awesome. Well, thank you very much. Next week, we've got, like I said before, to my other class, we have a former student of mine who's actually Gio. He's working for Allianz in Munich, in Germany. And so he's running their kind of their sustainability and ESG part of their business, but then also dealing a lot with climate adaptation projects and looking at ways of assessing risk and the financial aspect of risk in various countries where they're, you know, underwriting and doing risk, you know, financing and insuring infrastructure and so forth. So that'll be next week. Different time is going to be in the morning because of time difference, but that should be a great one too. A good kind of extension of what you've told us today. So thank you very much, Gio. Appreciate it. You've got a dinner coming or lunch coming your way, and you can invite some of your colleagues or one of your colleagues. There's two. I'll give you a quota of two. But appreciate it. So anybody, if you have any questions, feel free to shoot them to me and we'll get some input from Gio. But thanks for coming out, everybody, and we'll see y'all soon.
Thank you. See you. Bye-bye.